Assalamu alaikum everyone. So let's start with our next topic on compass traversing. So before we go into detail of compass traversing, let's first see what is the difference between triangulation and traversing. So basically both are used to gain horizontal or vertical control over an area, and triangulation is basically when if this is the area that you want to serve it. So triangulation is when you choose points and then you join them by making triangles. So in this process, what you do is that first you choose one line. Let's say I have chosen this line AB as my baseline. So baseline is a line whose length is measured very accurately. And when I say accurately, it means that whatever corrections you have studied in the previous lecture, you apply them so that the length of this line AB is very accurate. Why does it have to be very accurate? Because the benefit of triangulation is that when you have to do a lot of measurements, if you use triangles, then you don't have to measure every line individually. So by using the equations of triangle or trigonometric laws, we can calculate different lengths by using the lengths that you already have and the angles that you already have. So it really reduces your work. But the condition is that the first line, the lines that you measure, have to be very accurate because an error in those lines will be transferred to all the other calculations that you do to find out lengths and angles of other sides and other lines. So this process is called as triangulation. Alternatively, if you want to survey the same area, another process is not to do survey like that by making triangles like we do in triangulation, but to make a scheme which is called as a traverse. So the difference between triangulation and traversing is that in traversing you form an open loop, an open traverse or a closed traverse. So the closed traverse is also called a loop, which I have drawn over here. And the open traverse would be just a series of lines, and they don't connect with each other, so that they don't form a loop. So this would be an open traverse, and this would be a closed traverse. So as you can see, the difference is that we don't have to make triangles. So traversing is uh, preferred when the area to be surveyed is has a lot of undulations. It's difficult to measure horizontal distances, and you just want to get done with the work quickly. So that is when you use traversing instead of triangulation. So in traversing, we have different methods. The first one that we're going to cover in this lecture is compass traversing, but we also have satellite traversing that we will cover in the lectures to come. So, talking about compass traversing, I've already discussed why traversing is done. It's a framework of connected lines, and the lengths can be measured by measuring tape or other instruments. But the difference from triangulation is that the number of calculations or the number of measurements get reduced. And for measuring the angles, you can use compass, which actually gives you bearings, and then you can convert those bearings into angles. So before we get into how we calculate or how we read the bearings, first we have to understand some differences. What are true meridians, magnetic meridians? So let's see this with the help of a figure. So our Earth has a geographical north and a geographical south, and your compass points towards that geographical north and geographical south. So the line which joins the true geographical north, geographical south, that is called as a true meridian, which you see over here represented by GN. But with that, you also see we have this magnetic meridian. So the difference between true meridian or the geographical north or the magnetic north or the true meridian and the magnetic meridian is that while your compass should point towards the geographical north, there is sometimes an error, and that error is called as a declination. So while your compass should be pointing towards the geographical north, it doesn't. It points toward this other direction, which is called as magnetic meridian, and the difference between the two can vary depending on which location you are performing the survey, what time of the year it is, what season it is. So a lot of factors come into play. But the bottom line is that your compass, your freely suspended compass, does not point towards the true north. So that hence we have the difference between the true meridian and the magnetic meridian. Now, if we talk about the true meridian, it is a line passing through the geographical north, geographical south, and any point on the surface of the earth. So that is called as true meridian. So it's and it is constant at a station. And the angle between the true meridian and the line is called as true bearing or azimuth of the line. So if you see over here, if this line shown in blue is your survey line, and when you draw it over here, so if this is the survey line, and you place your compass over here, and you view the point B through your compass, through the object plane or side plane. Now, your compass, the bearing it will show, it will be, let's say the north is over here, it will give you this bearing. Now, the bearing that will give you would be the magnetic bearing, because like we have discussed, that a freely suspended compass does not give you the true bearing, it gives you the magnetic bearing. Now, if somehow by applying corrections we can get the bearing from the true north, that would be called as azimuth of the line. Now, the whole circle bearing and the quadrantal bearing. The difference is that the whole circle bearing covers a whole 360 degrees, while in quadrantal bearing, we convert the whole 360 into four quadrants. So that means in one quadrant, the maximum angle that you can get is 90 degrees, while in whole circle bearing, you get 360 degrees, and in quadrantal bearing, you get 90 degrees. So if you see the definition of the whole circle bearing, it is the magnetic bearing of a line measured clockwise from the north pole towards the line is known as whole circle bearing. So it's always measured clockwise. So let's see it on this figure. Uh, the whole circle bearing, like we have discussed, would be from 0 to 360 degrees. And if I draw the quadrants over here, north, south, east, and west, so the whole circle bearing is simple. It would be a whole circle 0 degrees at the north, and then 90 degrees at the east, 180 degrees at the south, 270 degrees at the west, and again 360 degrees at the north. But the quadrantal bearings are always from either the north pole or the south pole. So that would mean that in the quadrants in the north, it would be either in the quadrant of northeast, starting from 0 degrees at the north, 90 degrees at the east, or it would be from the northwest, again starting from 0 degrees at the north and 90 degrees at the west, or it would be from the south, 0 degrees at the south and 90 degrees at the east, or from southwest, again in the same way. So the while the whole circle bearing always starts from the north and covers a whole 360 degrees clockwise, the quadrantal bearings start either from the north or the south, depending on where the angle is, and they would be from 0 to 90 degrees, starting always from the north or the south. And the notation for them is north, whatever the angle is, sorry, the bearing is from 0 to 90 degrees, east. Similarly, south, whatever the bearing is, west or east. So this is the notation for the quadrantal bearing. Now, two terms that we'll be using a lot, the forebearing and the back bearing. So they basically mean that when you're doing traversing, and let's say if this is my traverse, I have A, B, C, and D. So the forebearing and the back bearing depend on the direction of your survey. So if I am starting at A and I am moving in this direction, so this is my direction of survey, placing my compass at A and looking at B, the bearing would be forebearing. Placing my compass at B and looking at A, that would be my back bearing for the same line. So every line has two bearings, a fore bearing and the back bearing. And they could be from either direction, it doesn't matter. It just depends on in which direction you are serving. Alternatively, if I am serving in this direction from D to C, standing at point D and looking at point C, the bearing would be fore bearing. And standing at C, looking at D, the bearing would be back bearing. So it is just a convention. But the point to remember is that the difference between forward bearing and back bearing is always 180 degrees. So let's see it over here in this figure. So this is the direction of the north, and if the direction length of the line is not too much, that means the direction of the north would remain the same, standing at either points. So let's say this is point A and this is point B, and I am standing at A looking at B. So this angle over here is my forward bearing of the line AB, and standing at B looking at A, the bearing is always clockwise. So this would be my back bearing of the line AB. Now the important thing to remember is that the difference between the forward bearing and the back bearing is always 180 degrees. And you can see it over here in this figure. If you project this line further, now what is this angle? This angle is similar to the angle over here, right? So if you subtract from the back bearing of the line BA this angle, you are left with 180 degrees. So this is how the difference between forward bearing and a back bearing of the same line is always 180 degrees. And this is actually a check whenever you perform survey in the field and whenever you take the forward bearing and back bearing of a straight line. So the difference between the two should always be plus minus 180 degrees. If it isn't, that means either you performed it incorrectly or there are some other errors that we'll talk about in a short while. So, magnetic declination. So, like I told you before, that the true north or the geographical north is different from the magnetic north. So, whatever the compass is pointing towards, that is not exactly the same point as to what it should be pointing at, and that difference in angle is called as declination. So, the declination can be west or east depending on uh, where the compass is pointing. So if the compass is pointing towards the west of the true north or geographical north, that would be called as declination west. And if it is pointing towards the east of the true north, that would be called as declination east. So that was about the theory of the compass. We still have to cover the errors, and we also have to cover different parts of the compass. We'll do that in the next lecture. But before that, in the next video, we'll try to solve a couple of numericals.